Hi everyone, welcome back. Today we're doing valid palindrome. This is a variant of typical palindrome checking questions. In this case, they consider a palindrome to be if we convert all uppercase letters to lowercase letters and we remove all non-alphanumerical characters, inclusive of spaces and commas, it reads the same forward and backwards. And alphanumeric characters include letters and numbers. So given a string S, we will return true if it is a palindrome or false otherwise. So for example, a man, a plant, a canal, Panama. So in this case, the output is true because if we get this intermediate string, after lowercasing all characters and removing all non-alphanumerical characters, then we get a palindrome over here. Similarly, for race a car, removing the spaces gives us race car, race a car. So in this case, this is not a palindrome because it doesn't read like the same backwards and forwards. So notice that it's all fine from RAC to RAC over here, but from this point onwards, E and A are not equals to each other as you read them back and forth. So this is not a palindrome. And for the final example, an empty string, this is considered true because it reads back and forth for a single empty string. So for this test case, every S given to us would have a length of 1 to 2 to the power of 2 times 10 to the power of 5. And S consists of only printable ASCII characters. So that's pretty much it for this question. So our approach for this, one possible approach is to lowercase all characters and also remove out all the non-alphanumerical characters. So we will do a linear scan across S to do the string processing first, and then we would check whether if this remaining string is a palindrome or not. So we will first define, let's call this our intermediate palindrome. Let's call this a string and initialize that to be an empty string first. Now the next thing we do is for character in S, we will do a linear scan from left to right in S, and we will proceed to lowercase the characters. So if the character dot is numeric or character is alpha, then in this case this is a valid character. So what we will do is we will append this, we will just append this string after lowering it. So after this iteration over here, our intermediate palindrome should contain all characters that are alphanumeric and lowercased. And afterwards, we can use this intermediate string to do a check. So one way we can go about this is by iterating for index in length of intermediate palindrome floor division 2. So if you are having an intermediate palindrome, let's say equals to ABC, AB, BA, in this case, then the intermediate palindrome length is 5. So 5 floor division of 2 will be 2. So this will be evaluated to 2. So I missed out a range over here. So range of 2 means you iterate on index 0 to index 1. So using this index 0 to index 1, we can use this to get a left index and a right index. So let's do left index equals to integer equals to 0 equals to 0 plus index, and right index will be equals to length of intermediate palindrome minus index. So -1 minus index. So we will go through the tracing over here, but the idea is that the left index will be pointing to the first character, and this will be pointing to the second character. And using this index over here, we will be able to slowly move this towards the center, and as long as the characters are equal to each other, then we will consider that as a palindrome, otherwise false. So that's pretty much the idea for this algorithm over here. We are just using 2 pointers in effect to iterate the characters in the intermediate palindrome inwards towards the center. I'll be using this left and right pointer to check whether if the two characters are equal to each other, a property of a palindrome. So at this point, we will also define an isValid. We will set this to be true, and this string over here will be considered as a palindrome until proven otherwise. So if s at left index is not equals to s at right index, then what we will do is we will set isValid to false, and we will break this iteration, and we will just return isValid like this. And that's pretty much it. So this is pretty much the algorithm. So let's try it out with this example over here. So a man, a plant, a canal, Panama. And let's set this intermediate palindrome to be an empty string first. We'll be tracing everything out one by one. So for character in S, the first character is A. And in this case, the character is numeric. So this is true or false. So this will evaluate to true. And we will append this character A into intermediate palindrome here. Next is a space. Space is definitely not numeric or alphanumeric, so this will be skipped. And we will go to M in man. And in this case, this would be false, but this will be true. So in this case, this will be appended here. We have A next. Similarly, this is the same situation. And the next character is N. Same for this. And we have a comma. In this case, this will be false because the comma is not numeric or alpha. So we will skip the comma. And we have a space. Similarly, we'll get false for both cases. And we'll encounter A. So we will put A here. This is false, but A is true. Pardon me if I make any mistakes, but that's pretty much the idea. Afterwards, we have a man, right? So, and a plant. A man, a plant. Okay, I think I missed. Okay, so I'm currently at P over here. A man, a plant. So P, we'll put P here. And similarly, we have L. We are currently here for our viewers who are wondering where we are. So we are L over here. Let's continue. So we have A in plan. We have N in plan. We have a comma, and this is false. So we skip that. And we have a space as well. So we are here. Okay. And now we finally encounter A again, and this is true. So we put an A inside here. And we have a space. This is false. And now we have C. This is back to true, and we'll put C here. A. N. N in canal. A in canal again. And finally L in canal again. So we will now encounter a colon. Colon in this case is not alpha, so this is false. And we skip that. We encounter a space, we skip that. We encounter P. In this case, this will be true. And we will append P in Panama, A in Panama, N in Panama, A in Panama, M in Panama, A in Panama. So A, N, A, M, A. So I skipped some steps here, but you get the idea. So is this equals to the same intermediate palindrome that we have? Yep, that's pretty much the same. Yep, it is the same. So yep, our tracing from line 10 to line 12 went well. So let's set this to this. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 characters. So this is of length. Length is 21. So 21 floor division is 10. So range 10 over here effectively. Index is now set to 0. So we will iterate from 0 to 9. So now the left index is equals to 0 plus index. So left index is equals to 0. And right index is equals to length of intermediate palindrome minus 1, so 21 minus 1, 20, 20 minus index 0, so 20. So that's pretty much the state of where we are right now. So now we are checking left index and right index. So for simplicity, I'll be leaving the first character here and the final character at the back here. So A is equals to A, so in this case this is false, and we continue. Now we move on to index 1. Left index will be 1, right index will be 19. Now this will point at M, and this will point at M as well. So this is still false. We continue, index 2. Left index is now 2, right index is 18. So this is A, and this is A as well. This is the A here as well. So we continue, this is still false. We continue, left index is now 13. Now we're at 17. So now we're at N. So false. So let's continue, index 4, 16. And you can get the idea, you pretty much get the idea over here. So this is 15. We're currently targeting P now. So P as well as the P over here in Panama. So P and P, this is still false. Let's iterate forward, closer, 6 and 14. So now we are at L over here, and we are at L over here as well. So this is L and L. Similarly, L and L are still the same, so that expression here is still false. Now we have 13, 17 and 13. So now we have A, and we have A over here as well. So this is the same. This is going to be true. So 8 and 12. Now we are at N and N over here. So N and N, this is still equals to each other. So we continue, 11. So now we are at A and A over here. So this is the final iteration, because range 10 will just iterate from 0 to 9. In this case, this will just be, this is still false. So that's pretty much it for line 16 to line 24. We pretty much do a single iteration towards the center for using both pointers, and we're checking each character on both pointers to see if they are the same. And if they are not the same, then that is not a valid palindrome, and we'll just return false. So it looks like everything is great. Let's implement this. So let's define the intermediate palindrome. This intermediate palindrome will contain all characters in S which are alphanumeric. So for char in S, we will start to populate intermediate palindrome if character.isnumeric or character is alpha. Then what we will do is we will append this current character, but we will lower it in case it is not lowered. So character lower like this. And at this point, our intermediate palindrome contains all characters that it needs. We will set is valid to true, and we are ready to start doing the check using the two-pointer method to see if this intermediate palindrome is valid. So index in range length of intermediate palindrome, and we will floor division this too. We'll be using this index we'll be using this index to move the left and right index closer towards the center. So left index is 0 plus index, right index is length of intermediate palindrome minus 1 minus index. And over here, we'll do if left index is not equals to S right index, then we will set is valid to be equals to false and break. In other words, if the left and right pointer are not equal to each other, then we would just terminate the search and just return false. So that's pretty much it. This is pretty much the solution. Let's just take a look through the solution again. So we have an intermediate palindrome. We get only the numeric and the alpha characters, and we lower each of the characters before we continue. And then we proceed to check the intermediate palindrome if it happens to be a palindrome using a left and right pointer slider. So for our viewers who are aware, that is actually a faster way for you to check if something is a palindrome or not. You can just do intermediate palindrome equals to this. So this is very simple. If you are not confident under interview conditions to implement this, it's totally fine. You can stick to this. The only drawback is that you are going to use ON time regardless of whether if you could terminate early on as you do the scanning. So this implementation is easier to mess up during technical interviews, but if you are comfortable and you use this enough, I would recommend this. This would probably impress the interviewer a little. But if you are crunching for time, this is totally fine. I don't think you'll get faulted much for that. But anyway, this looks fine. Index looks great. Yup, this looks great. Let's run this code. Wow, why did this become false? Expected is true. Okay. Okay, I'm pretty sure I was tracing this correctly just now. Or did I make a mistake earlier? Okay, this valid equals to false. Length of intermediate palindrome. Floor division 2. Index equals to index minus 1 minus index. Index right index is valid is equals to false. Break. So perhaps the check here went incorrectly. Let's quickly, okay, I'm cheating a little bit here, but just to check whether if like this is true for, okay, this is not very helpful. So, and this. Let's print out the char together with the check over here. And let's see if the intermediate palindrome was read in correctly. So I see, oh, okay, it's supposed to be R, not. Okay. So let's see each of the characters. So this is true, 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 true. Okay. What is the, looks like everything is fine though. Looks great. But okay, perhaps the intermediate palindrome is not the right expected string, perhaps. Let's take a look. Ama, plana, canal, Panama. Okay, intermediate palindrome looks fine. And we return false. Okay, let's print out the left index and the right index. Curious, why did I miss this out during tracing? 0 to 20. So at 0 and 20. So A and A. Oh dear, of course it would have went wrong. I was supposed to lower this. Oh, I was supposed to use the intermediate palindrome for the check. So the mistake was that I used that left and right index, which was referring to the index in intermediate palindrome, to check whether if the left and right pointer are equals to each other. So please be careful. In this case, it's actually quite depressing that I didn't notice this during tracing, but this should pass now. Okay, let's submit this. And that's it for the solution. So I cheated a little bit at the end because under technical interview conditions, I should not be allowed to run the code all the time. I should have looked a little closer. It was actually surprising that I didn't notice this even during tracing. So as you can see, it is possible to make mistakes during tracing and you might mess it up. So don't be like me, please check your code properly. So in this case, let's go through the time complexity. So if we let n be the length of s, we are iterating all characters in S, so this is going to be ON over here. And we iterate through the intermediate palindrome. In the worst case, the intermediate palindrome would share the same length as S if S contains all numeric or alphabetical characters. So in this case, this is going to be iterating ON floor 2, but if you remove the coefficients or divisions, this is going to be ON as well. So in this case, the time complexity is O2n, but if you remove the coefficients, this will be On. For the space complexity, we are keeping track of a copy of S over here as well. So the space complexity here is going to be On. And let's continue and take a look at the rest. Yep, everything here is not going to use any additional space that scales linearly with n. So the space complexity here will be On as well. And that's pretty much it for this question. If you like this, please give us a like and subscribe, and we will see you in the next video.